All right, so L1 is going to be how to find limits graphically. Okay, so the first thing that we're going to do is write down what the mathematical definition of a limit is. Okay, so you can look it up in Google if you would like. Hold on. There we go, perfect. Okay, so it says in mathematics, a limit is the value that a function in a function or sequence approaches as the input or index approaches some value. Okay, so maybe that makes sense to you, and I'm gonna guess maybe it doesn't. So what that really means is a limit is the y value that a function approaches at some given x. Okay, and the key piece behind all of this is that word approaches. Okay, so if you're tracing a function from the right or from the left, what is the y value that that function is approaching? We'll come back to this, explain what a limit is. Okay, so here is a kind of a little cute idea of a limit and understanding where things are going. Okay, so it says we want to live in a world where it doesn't matter what side you come from, all that matters is that you're going to the same place. Okay, so making sure that from the right and from the left, these ants are going to the same place. Okay, so we're going to decide if we have happy ants or not. Okay, so if you look at point A, are the two ants going to the same place? Okay, so yes, these two ants are going to the same place. These are happy ants. Okay. For this one, these ants are also both going to the same place. They're both going to the top of that hill. So these are both, again, happy ants. Down here, now this ant is going to this lower place, and this higher ant is going up here. So these two ants are not going to the same place. So when they're not going to the same place, that means that the limit for this scenario does not exist. Okay, so those are unhappy ants. Okay, at D, there is a hole right here in the function, but still both of these ants are going towards the hole. So these are happy ants. They're going to the same place. Okay, now E is kind of a unique situation because what's happening in this particular graph is we have like a vertical asymptote. So these two ants are going down, but they're both going down to infinity. So this is actually a scenario where you could have two potential answers. You could have an answer that, yes, both ants are happy because they are both going to negative infinity. Or you might say that negative infinity is not a number. Okay, I can't give you an infinite number of pens. So some mathematicians would argue that that is not a place, so therefore the limit does not exist. So we will answer this both ways. So we can say it does not exist or negative infinity. I would accept both those scenarios. At point F, these two ants are clearly not going to the same place. So at F, the limit does not exist. And at G, this is a kind of unique scenario where I only have the left ant. There is no right ant. So since there's not two ants going to the same place, then we have to say that the limit does not exist. Okay, so this next little piece kind of runs through the idea of limit notation. So we're going to do these three examples. Okay, so I'll write this up here. So it's up next to the graph. So the first one reads, the limit as x approaches -1 of our function. Okay, so this right here is an entire graph of our function. It's a pretty unique function. It's probably made up of different pieces, but overall this is the idea. Okay, so what we're going to do is we're going to get really close to the x value of -1. So x value of -1 is about right here. So if we were pretending to be little ants along the function, we're looking for the y value that these ants would be approaching. Okay, so from the right and from the left, are they first of all approaching the same place? Okay, and they are in fact approaching this little point right here. And that y value would be 1, 2, 3, 4, 5. So that value would be 5. So the limit as x approaches -1 of this particular function is 5. Okay, the next one is the limit as x approaches 3 of this function. Okay, so as x approaches 3, so here's 3, so this is the place that we're looking at. Okay, and it does have a hole, so the function value is undefined at 3, but what is the graph doing from the left and from the right? Okay, so on the left side, the function is going to that hole, and on the right side it's going to the hole, so that hole, the y value, is in fact 3. Okay. Alright, so the last one is the limit as x approaches -5 of our function. Okay, so -5 right here, you can see that there's this vertical asymptote. Okay, so splitting the function apart. And on the left side, this function is going down. Okay, and it's going down to -infinity. And on the right side, this one is going up. So are those two ants going to the same place? They're not going to the same place. So this would be a does not exist. Okay, so we'll do a couple more, just to kind of make this a little bit more concrete. Okay, so let's say this is my new function. Okay, again, it's pretty gnarly, but that's okay. We'll do a couple different spots here. Okay, so our first one we'll do the limit as x approaches 0, okay, of our function. So if we go to the x value of 0, okay, we're going to this spot. So from the left, it's going there, and from the right, it's going to that point. So I would say that the y value that that's going to is 3. So the limit as x approaches x approaches 0 is 3. Okay, what about the limit as x approaches 1? Okay, so take a look at that as x approaches 1. Okay, so when x is 1, we're looking at about right here. Okay, right where that hole is. Now on the left side, it's going to the hole, which has a y value of 2. And on the right side, it's going to the hole. So I would say that this function is going to 2. Okay, now this is a really good time to bring up the fact about the separate question. What is the function value when x is 1? Okay, so now this is really an algebraic idea, whereas limits are more of a calculus idea. Okay, trying to figure out what a function is approaching without knowing exactly where it's going, whereas 3, that's asking you for a specific point. Okay, so the point at -1 is the hole. So there is no point, so this is an undefined value. And we can say it does not exist. Okay. Let's try another one. Let's say the limit as x approaches -1. Okay, of our function. Okay, so on the right and the left, do these two ants approach the same place? Okay, so we're looking at -1. On the left side, it goes to the y value of 1, but on the right side, it goes to the y value of 2. So are those two ants going to the same place? No. Okay, so this does not exist. Okay, so speaking of from the right and from the left. There is something called one-sided limits. Okay, so if I want to say the limit as x approaches -1 from the left, I use a little minus sign right there after my x value. So that is a notation meaning from the left. Okay, so the limit from the left of -1 is going to the y value of 1. And if I said the limit as x approaches -1 from the right, I would use a plus sign. So that plus sign means from the right. Okay, so on the right side of -1, we're looking at that y value, so that one is approaching 2. Okay, so these are one-sided limits when you see that plus or minus. If you don't see that, you have to consider both sides of your limit. Okay, that's where the ants idea comes into play. Okay, maybe we'll just do a couple more and just make sure we've got this nailed down. Okay, so new graph. What is the limit as x approaches 0? Okay, so if you're looking at 0, this line is continuous. From the left it goes to 1, and from the right it goes to 1, so therefore the limit value is 1. Okay, how about, let's say, what is the limit as x approaches 1 from the left? Okay, so from the left side, we're going the values that are just slightly less, so infinitely smaller than 1. So what is that y value that's approaching? That value is 2. Okay, what if I ask you, what is the limit as x approaches 1 from the right? Okay, from the right. So just to the right of 1, infinitely close, we're looking at this spot right here. So that value is 1. So if I combine that and now say, well, what's the limit as x approaches 1? Are they going to the same place from the left and from the right? Okay, and there is not a continuous line, there's a jump in the graph, so that would be it does not exist. Okay, and if I asked you, well, what's the function value at 1? What is the point when the x value is 1? What's that corresponding x? Or excuse me, corresponding y, so that would be the point. Remember that that's a hole, it does not exist there, it's the point, so that y value is 1. Okay. Maybe one more. What is the limit as x approaches -2? Okay, at -2, from the left it is going to that hole, and from the right it's going to the hole, so that y value of the hole is 1. Okay. Alright, so hopefully that should be enough to make that make sense for you.